Okay, now it is going to the live. All right, hello students, how are you all? Good morning. And now we started another live. You just kindly check that whether it is you're finding everything or not. If you are finding everything, then we are going to start. Check the clarity and all, then we can start. Fastly check. All right. Today we are going to discuss exercise number 9.4, 3, 4, 5 questions. So before going to discuss that, let us close our eyes and then we'll do prayer. Then we can start our class. God kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Okay, so let us go for now our problem number 3, which was given. It is 3 into 1 square plus 5 into 2 square plus 7 into 3 square plus and so on. Okay, so before going to this, you know how to find first nth term. You know that whichever the series is given, first find the an, then go for your summation of that, then you are going to get your Sn value. And it was very simple question, just concentrate now. So now first you can write 3 comma 5 comma 7 and so on in terms. Because here two terms you multiplying. So first one an is equal to, second one it is 1 square comma 2 square comma 3 square comma and so on in terms. Okay, now see what I am going to do from this. So now in this is equal to what we can write, just concentrate. So now here it is 3, 5, 7. What is common difference here? 2, here also 2. So now from this, D is equal to 2 and A is equal to 3. So here from this we know that A is equal to 3 and D is equal to 2. By using this, just find the nth term of this. So now we can get A plus, we know that An is equal to in AP, A plus N minus 1 into D. So use that formula. A means here 3 plus N minus 1 into D is nothing but here 2. That into 1 square, 2 square, 3 square dash n terms is what we are going to get. We are finding here each one is like 1 square, 2 square, 3 square. So what we can write? Clear sir, but I am not found full board in the screen. Is it right? 1 minute, let me check that. Just like the screen full board. Okay, so here I was writing from this place. I think from this place, unless you are finding all the whichever is there, those all right. So full board is not required actually. From where I was writing, that part only required. That's the reason I only myself kept that side. Okay, there was some space I was kept. Okay, Garima, I think you are understood that. Okay, anyhow, just concentrate here. 1 square, 2 square, 3 square, and so on. N terms is there, that is called as n square. So directly you can write that as a n square. So now I'm directly writing this one as n square. Now, because you are finding each one number square is there, so directly it is going to be n square. See, 1 square, 2 square, 3 square. Last term, what is there? N square. That is nothing but your a. So now just we'll simplify this. Now 3 plus 2 into n, 2n minus 1 into 2, 2. That into n square. So now 3 minus 2 is nothing but 1. So at last 2n plus 1 into n square. Just this simplify it, you are going to get an of this complete series. So now let me simplify 2n into n square, n cube plus 1 into n square, we can write it as n square. Okay. After writing this 2n cube plus n square, then what we'll do here it is an we found. After that, we need to go for summation of this. So now we can write Sn is equal to. So now first one it is we can write 2 instead of n. What we need to write k. So k is equal to 1 to n cube plus sigma k is equal to 1 to n square. You know n cube formula and n square formula. Yesterday I said three formulas you have to remember. First formula it is 1 sigma 1 n is k is equal to 1 to n is there n into n plus 1 upon 2. Sigma k is equal to 1 to n square. So that is here we can write it as k. K and this as k square is equal to n into n plus 1 into 2n plus 1 upon 6. If it is k cube, so it sigma summation of 1 to n terms, k cube is equal to n square n plus 1 whole square upon 4. So now these formulas you should remember, and these formulas only we are going to substitute in this. Okay. So now let us see now in this place n cube. So here not n cube k cube and this has k square. Now sigma k is equal to 1, k cube means this is a formula. Sigma k is equal to 1 to n k square means this. Sigma is nothing but here sum of 1 to n terms. So now that is equal to 2 into summation of 1 to n k cube is nothing but n square into n plus 1 whole square upon 4. Write that n square into n plus 1 whole square upon 4 plus now sigma n sorry, k is equal to 1 to n k square. K square is nothing but you have this is formula, write down that n into n plus 1 into 2n plus 1 upon 6. Now let us see here 2 ones are 2 twos are 4. So now what I can write here, which is left that part here down. So n square n plus 1 whole square. Concentrate clearly, then you can understand. Upon 2 is there, so write upon 2 plus n into n plus 1 2n plus 1 upon 6. So in both places n into n plus 1 upon 2 is common. Here square is there means 2 times it is there. So here also n into n plus 1 is there. This 6 we can write it as 3 into 2. So that n into n plus 1 upon 2, n into n plus 1 upon 2 common. When you common what is left here? N into n plus 1 is left. Plus already this is common. Then what is left? 2n plus 1 upon 3. So write 2n plus 1 upon 3. So now take the LCM and solve. So n into n plus 1 upon 2. When you take LCM, 3 into n into any of this simplified. N into n square plus n into 1 n plus 2n plus 1 upon 3. So LCM we took, then what we are going to get, let us check now. So that is equal to n into n plus 1 upon 2. Now 3 into n square, 3n square plus 3 into n, 3n plus 2n plus 1 upon 3. So now what we are going to get from this? So that is equal to n into n plus 1 upon 3 and this 3n square. So now after that plus 5n plus 1 upon 3 and this part is 2. So n into n plus 1 upon 2, 3n square, 5n plus 1 upon 3. So now how to solve this one? So to solve this one, n into n plus 1, that is 3, 5, 1 plus 1. So how to solve? What do you know about this? So you just take this factorization you can do and then find your answer. So we have to find that answer. What we can do in this? How can we solve this? Hmm? So at last, anyhow, this part simplification required. This last part you only solve, complete it, and in the classroom show to me. Okay? That is about your problem number 3. Your main important points here, remember carefully. First, you need to take the series and then find the nth term. Then apply the summation for that. You will get some equations. Then after that, when you solve that, you are going to get your nth term. Okay, that is about your problem number 3. Let us go for problem number 4. I hope you are able to solve the remaining part. Why to solve this last calculation part? Okay, you are ready to solve that. Garima, you are ready to solve that, or you want me to help? So fastly tell to me that so that let me solve if you want. So you can solve. Okay, very good. So let me go for next part. Only that much part you can solve that. So if you are not able to solve, then I can help. But I think you are able to solve. Okay, let us go for fourth also. Now only 3 problems today we are going to discuss because of our time constraint. So only 15 minutes is left for us. Within that 15 minutes, I have to finish. So these formulas, just remember now. Next time, I don't want to write again here on the board. Right. So next one it is problem number 4, which is giving us 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus and so on. This is very important question, and this kind of question always it is very important. Just concentrate why it is going to be important question. So now first here it is the given, this is your SN. So from this we need to find our AN. So to find AN, you are observing 1, 2, 3, these are in one series, 2, 3, 4 again in the AP. So what I'll write is AN is equal to 1 upon. Anyhow, this little bit easy method I want to solve. So what I'll do here it is, so can I write now I'll write first terms, that is A1, A2, A3 and so on. I'll write up to n terms. Okay. Otherwise, directly also we can write no problem, but I'll go for some of easiest method now. So first I'll go for A1. A1 is 1 upon 1 into 2, right? This can I write like this? Check now. 1 upon 1 minus 1 upon 2. 2 ones are 2. 1 ones are 1. 2 minus 1, 1. 1 into 2 you are going to get. And let's check second one also. A2 is equal to 1 upon 2 minus 1 upon 3. Can I write? Check now. 3 minus 2 is nothing but 1. 2 into 3. So we can write in this form or not. So tell to me that fastly. So A3 we can write it as 1 upon 3 minus 1 upon 4. So in this method only you can go so that it becomes as easy for you all this problem. If you go in other method, it is not possible to be solved in a good manner. Okay, means which is your answer that you could not able to get. So next and so on. If I go for AN, what is the possibility here? So AM means what we can write here first? 1 upon n minus 1 upon n plus 1. So check now carefully. 1 is there, 1. Then n plus 1. 1 plus 1 is nothing but 2. Then here n is 2. 2 plus 1 is nothing but 3. Now here 3. 3 plus 1 is nothing but 4. That was the reason an is equal to 1 upon n minus 1 upon n plus 1 written. Clear up to here? Any doubt? An is equal to 1 upon n minus 1 upon n plus 1. Up to here, you have any doubt? Anyone having any doubt? I think no one having the doubt about this. So up to here, if you are able to understand, let us go for now summation of this. So now add all what we are going to get. When I add sum all, so that is only write our summation. A1 plus A2 plus and so on plus AN. That is nothing but your Sn. And here this is equal to add all. 1 upon 1 minus 1 upon 2. And here it is plus half minus 1 upon 3 and so on. So here which are going to be cancelled? This and this going to be cancelled. Minus 1 upon 3 and plus 1 upon 3. Here last place what you are going to get here that as minus 1 upon n and plus 1 upon n get cancelled, and here minus 1 upon n plus 1 is going to be left. So anyhow I am going to write that part plus 1 upon 3 and so on. Last one is minus 1 upon n plus 1. So remaining all are going to get cancelled. You are going to get only these two terms. What are those? 1 upon 1 minus 1 upon n plus 1. This is your Sn. Sum of all the terms is nothing but Sn. Okay. So now here Sn is equal to, just simplify this part, n plus 1 into 1 n plus 1 minus 1 into 1 1 upon n plus 1. Minus 1 plus 1 get cancelled. Sn is equal to n upon n plus 1. This is the easiest method. If you go for some other methods, that methods are going to be failed, because when you write here 1 upon, this is direct method, what you will do, 1 upon n into n plus 1 you will write. When you write this, so when you are doing the summation, it is going to be failed. So because of that reason, I am not going for this, and directly I went in this method. So we need to write in the separation form, then again we need to solve. I hope no doubt up to here. So is there anyone having any doubt in this? You can ask me. First, what I was done, 1 upon 1 into 2, we written as 1 upon 1 minus 1 upon 2. Let's check this part whether it is right or wrong. 2 ones are 2, 1 ones are 1. 2 minus 1, 1 you are going to get, then 1 into 2 is LCM. Same method here, 3 minus 2 is nothing but 1, then 2 into 3. As it is, you are going to get. So at last, up to an I was written, that is equal to 1 upon n minus 1 upon n plus 1. So after writing this, summation means what? Adding all the terms. So add all the terms. So then minus 1 upon 2 plus 1 upon 2 minus 1 upon 3 plus 1 upon 3. So that means here minus 1 upon n, here also plus 1 upon n get cancelled. At last, first term and last term is going to be left. So then first term is 1 upon 1 minus last term is 1 upon n plus 1. So both of them you are going to get your Sn. Okay, I think no doubt and you have understood. Okay, last and final problem for today, that is fifth problem. So let us go for that fifth problem now. So I think this fourth one finished, and now we are going to the fifth one. So now fifth one, it is they given as 5 square plus 6 square plus 7 square plus and so on plus 20 square. This is the given. We can't say this is n square. So the direct method also is there and normal method also is there. How can solve this one? It is direct method is just like you can write it right here everywhere. It is just like n plus 4 whole square. So here what we can write here, n plus 4 whole square, right? You are going to get. This is a direct method. We check now. Let's take n is equal to 1. When you take 1 plus 4, 5 square, then n is equal to 2, take 2 plus 4, 6 square, n is equal to 310, 3 plus 4, 7 square. This is direct method. But how to solve normal method? Let us see that. General method, it is direct method. Direct method plus n is equal to n plus 4 whole square. Directly you can write and you can solve. Okay? So first I will do with the direct method, then I will go for normal method. Okay? So right, let us go for direct method first. An is equal to n plus 4 whole square. This is a direct method. So first I am solving with the direct method. So now n plus 4 whole square means we can write an is equal to n square plus 8n plus 16. Correct? So now what I need to do, summation I have to apply. So summation means what is the unit rate? So Sn is equal to, now summation of k is equal to 1 to n. This n square we can write it as k square plus 8 is there a constant, right? First sigma k is equal to 1 to n plus you need to write as k plus 16 is constant, 16 first right, sigma k is equal to 1 to n, nothing is there means that is 1. So now you know formula of sigma k is equal to 1 to n k square, and formula of sigma k is equal to 1 to n k, formula of sigma k is equal to 1 to n 1. So just substitute those. K square means you know formula n into n plus 1 into 2n plus 1 upon 6 plus 8 into, in your k is there, so that n into n plus 1 upon 2 plus next one it is 16, and you know that k is equal to 1 to n, 1 is there. 1 is added n number of times, you are going to get n. So that's 16n. Now let us see cancellations. What are the possible? 2 ones are 2 fours are 8. So let us see now what are the possibilities are there now to solve. In all the places you found as n is common first n. Okay, after common n, what is left? N plus 1 into 2n plus 1 upon 6 plus here 4 into n already common, then only n plus 1 plus n common, only 16 is there. So LCM you want to take as a 6, what is the possibilities to do that? So if you take LCM as 6, so then that is equal to n LCM as 6, then n plus 1 to n plus 1 as it is. So write that n plus 1. Anyhow, just if you want to simplify 2n into n, 2n square. Then next n into 1, n plus 1 into 2n, 2n plus then 1 into 1, 1. So this part is finished. Next, you just observe here LCM is, when you take LCM, this numerator is multiplied with 6. So 6 fours are 24. So 24 into n, 24n plus 24 ones are 24 plus next 16 is there. 16 is multiplied with 6. So 6 6 are 36, 6 1 6 plus 3 9, 96. So 16 into 6 is 96. So now finish this part. Now 6 we can keep like this, only later we will simplify. Let's simplify this part now. 6 is here. First n square terms, only 1 is there, so that 2n square. And then n terms, n plus 2. N is think as chocolate. 1 chocolate, 2 chocolate, 3 chocolate, and 3 chocolate, and 24 means 24 plus 3, 27n. So if you are feeling difficult, n is think as chocolate and then solve. So 24 plus 2, 26, and then 27. So totally you are going to get 27n. Okay? Then plus what is left now? 96, 24, and 1. So right here 96, 24, and then 1. So 10 plus 1, 11. So 10 plus 2, 12. So 121 plus 121. So check here, still anything is left. So I think everything is fine. This nothing is left in this place. So now we finished up to here, and you know that how to solve this all. So just factorize it and then solve this part, get your answer. Okay, I'm showing only up to here. You need to solve that and you have to finish it off because time is up hours. So tomorrow, mix in the classroom, we are going to discuss the remaining solution. Okay, so up to this I was told, and last what you need to do is just factorize it and get your answer. So in all the places, I'm leaving last factorization for you all only. You can complete it. Okay. All right. Today's class is finished. May God bless you all. All right. Completely struck.